During part A today, we're going to focus on the daylighting components of ClimateStudio. We have a second webinar lined up in 2 days at the same time on March 26, and there we're going to focus on the energy components of ClimateStudio. We will be recording the webinar today and the one on Thursday as well, and sharing links to everybody who registered in case you want to go back to the recording. So let's get started. Quick word of introduction. We are Solema. We are a software company that started about 10 years ago when the 5 of us met at the Harvard Graduate School of Design. Since then, 3 of us are still in academia working on environmental performance analysis in Toronto at Cornell and at MIT. And Jon Sargent and Jeff Niemasz are working full-time for Solema. As you see in the picture, about once a year, we are trying to reach out for more in-person meetings, which are preferred by everybody, of course, during our Solema Symposium. The picture that you see here is from the Solema Symposium this February at the HOK premises in Los Angeles. So before getting actually into the tool, it might be useful to just take a step back of why we are interested in reducing carbon emissions in the building stock. And I guess the 2 numbers that we are all aware of keenly are, on the one hand, that right now global temperature increases at around 0.8 degrees C. And last year, we globally emitted 37 gigatons of carbon per year. And now when we follow the lead of the IPCC, then we know if we want to, in the long run, keep global temperature rise below 1.5 degrees C, then we have in total about 580 gigatons of carbon left worldwide to burn until 2050. And if we assume now that buildings going to keep their 40% portion within that overall carbon budget, then we know we have about 230 gigatons of carbon left worldwide for buildings until 2050, when the building stock will have to be net zero. So we're thinking here in timescales that are not that long, so there's some urgency to the task for us to make buildings as resource efficient as we can, while at the same time, of course, maintaining the and ensuring the occupancy comfort in buildings. So how are we doing that? For us, we are focusing especially on the architects and their consulting to combining during the design process, design and environmental modeling within one environment. And while 10 years ago, that was maybe more of a dramatic or radical idea that architects should do performance analysis themselves, we are now at a point where the American Institute of Architects is endorsing that idea. Here in their recent report, there's this really nice quote: building performance simulation is no longer just a good idea for some architectural practices. It's an essential part of building design and delivery. And we all couldn't agree more at Solema. So how are we actually going about this? So we are assuming that you have your initial design. In this example, you have the corner of an office building. And now you're using a performance analysis using ClimateStudio, where you're looking at the daylight availability, the energy performance, and the visual comfort within your design. And in this case, you might find out that glare is a problem here. So then, of course, the big step is that the information is presented in a way that allows you to change your design, add a shading system, and then you redo your analysis and hopefully find some better results. And we are going to give you an example of that in the following, how to do this type of analysis. So one could say this is, of course, not a new idea. We've been doing that with Diva for Rhino for a long time, where we developed all this individual performance workflows. But by talking with some of our clients and firms with whom we work very closely, we found that even though it's accepted that architects using these tools during the design process, our tool and the tools of others very often have a hard time really getting to the core of it and helping architects changing their design process. So we wanted to overcome that by working for a full year with our so-called executive user group. These are 14 firms who engaged with us for the last 13 months now in a very intimate discussion back and forth. And as you see here, we've been working with manufacturers to ensure that the data in the libraries that ClimateStudio ships is all reliable. and with consulting firms and large and small architecture firms to ensure that the information are presented in a way that is usable for them. So the outcome or the main goals that were driving us during the design of the product is we wanted a simple user interface, way faster simulations than in the past, validated material libraries, data visualizations, and automated reporting. So as I said, initially we will be covering daylighting today. So we'll be starting off with a lead V4 daylighting analysis, followed built in with an annual glare analysis study. And towards the end, we'll be looking at electric lighting design in ClimateStudio as well. During Jon Sargent's presentation in the following, I'll invite you to ask questions using, if you're new to Zoom, there are basically two ways of communicating. There's the question and answer component and the chat component. Please use the question and answer part to ask your questions. While Jon is presenting, I'll be keeping tab on your questions, and then towards the end of the webinar, we'll be grouping your questions into larger topics and hopefully be able to address them all. So with that, I'm handing it over to Jon Sargent.
Okay, great. Thank you, Christoph, for setting up the context for today. Now comes the fun part where we get to actually open the software and talk through some of these capabilities. So ClimateStudio is a plugin for the Rhinoceros CAD environment. You should all see a Rhino application up in the webinar viewport. Is that so? Okay. Yes. Okay, great. Really two main functions of the demo today. So the first is I want to take you through a tour of the ClimateStudio interface so you can see how to run your own daylight simulations. And the second, in the 40 or so minutes that we have, is I want to actually walk through a short design exercise so you can see how ClimateStudio can be used to quickly improve the performance of a real project. And towards that end, we'll be using this office model, which you can see in the viewport here. And we can think of this as a typical floor plate in a larger office building. One of the nice things about ClimateStudio is that it's really been built to accommodate any level of geometric specificity on the daylight side. So whether you're working in the very beginnings of concept design and just have a basic massing with window openings, or you're very late in design development and everything is pretty much locked in and you're really just sort of tinkering with a woven fabric material or the right type of glass, you can use the exact same ClimateStudio workflows to address performance questions. So there's nice continuity there. For today, we're going to assume, just to keep the exercise a little bit interesting, that we're still in concept design phase. So I might imagine that the site and program and massing are kind of locked in. So I know sort of what the dimensions and where the core of this tower is. But let's imagine that the sort of detailed layout here, which I'm just throwing in for sort of visual realism, and the facade is totally up in the air. So if I am the design consultant or the architect on the project, I might be asked to come up with a couple iterations that improve the daylight performance of the skin. So where do I begin in that process? Well, for daylight, there are really two big categories of question that we want to ask. The first is there sufficient daylight? Meaning, does enough light pass through the facade and onto the work plane that people can do work tasks without the aid of electric lighting? And if so, that really has two benefits. So one, we replace the need for electric lighting, which cuts our energy bills. But then secondly, we also are guaranteeing a sort of sufficient supply of broad spectrum, blue enriched light that's going to keep our occupants healthier and more productive. The second category of question we want to ask is the space visually comfortable? And usually what we mean by that is there a relative absence of glare so that people are comfortable? And then as a corollary, do people actually have views to the outside, or because of glare issues are the blinds always closed so they can't see? You know, over the past year, we've really built ClimateStudio to make answering these types of questions very straightforward. So what you'll see in the interface is after you install CS, up in the upper left, there is a toolbar with a set of buttons. So each of these buttons takes you to a workflow. And the idea behind these workflows is they're supposed to take one of these fundamental design questions and produce a very clear result that leads to an actionable decision that improves your project very quickly. So taking the daylight sufficiency question, for example, one could look at the amount of illuminance falling on a work plane, either in a point in time or on an annual basis, which you might do for a LEED compliance study, for example. So taking the first one, just for simplicity, if you click on the point in time workflow button, you'll get a panel that opens in Rhino. And so this is a native Rhino style panel, which you can dock anywhere in the viewport, which I will over to the right side, along with my layers and properties. And for this workflow, as with the others, what you'll see is basically a list of input instructions. So stepping through from the top to the bottom, I see I can set the climate location, which I'll leave at Boston, which is sort of where we all met in Selema. The sky condition, where you can set for point in time simulations, the sky condition, and a date and time. Materials, which define the lighting or optical material assigned to each layer of the model. So we usually set up models in Diva or in ClimateStudio by layer, so that things like the floor and the ceiling and the walls have different optical properties. Now, another thing we've really worked to develop with ClimateStudio vis-a-vis older versions of the daylighting software is the library of materials you can choose from. So rather than just having a couple of kind of generic defaults, we've actually populated ClimateStudio with a library of hundreds of opaque and glazing materials that come from real measurements and validated sources like the International Glazing Database or ASHRAE, et cetera. So from this browser, you can search through material by type, opaque, transparent, translucent. You can also search by name. So if there's a particular type of surface you're looking for, you can see if they're relevant entries. And you can also sort by any properties. So you can sort by name, by optical properties like visible reflection or transmittance, et cetera. Now I've already set up this model with some basic materials. So that's kind of ready to go. And then the next step could be luminaires if I want to study electric lighting. I'll skip that now and come back to it later. And then finally, we have to set up areas or sensors where we're taking measurements. So here, if I click on add occupied areas, I can sort of select surfaces that I use as reference planes for measurement. So here I've sort of preset a couple of surfaces in the model here, and the sort of reception area and open office area. And so when I select those, I'll get a little dialog that pops up. It lets me set names for each area. I can sort of adjust sensor spacing. I can also adjust the work plane offset. So this is how far off of the finished floor the measurement plane is, or the work plane. So 0.76 meters is about 30 inches, which is the default for LEED measurements. But I can sort of increase or decrease that as I want. I'll leave it at the default for now. And once I set up those areas, I'll get a little table and I can go back and edit things after the fact. So I might call one area open office and another area the reception. Okay, and so for an initial study of point in time daylight, this is all I need. And so I click play. And now this is where ClimateStudio really starts to separate itself from other daylighting tools. So I'm going to dock the results panel next to my simulation panel. And what I'll see is that I'm immediately getting feedback in the viewport. So what we've done in the background is we've made the radiance-based calculation engine much faster than in Diva or in other daylighting tools. So what you're seeing here, and I can turn on the sensor values here and kind of zoom in, is I'm getting the illuminance at each sensor point in these occupied areas. And you'll see they're sort of jumping around a little bit, the values. What we're doing is we're running a progressive path trace, which is sort of a different version of radiance ray tracing than we would typically use in the past. But what this allows us to do is get back results very quickly. And they're accurate. The precision will increase as the number of passes increases. But as you'll notice, while the simulation was running, these numbers were only jumping around on the order of a couple %. So what we immediately see is the lesson we needed to learn, or the question we needed to answer, which was, at this point in time, was there sufficient daylight in the space? And so we can see we're actually flooded with light coming through the fully glazed facade, even towards the back row of monitors where people are working. We have close to 1,000 lux, which is more than what we need. We actually probably have excess daylight toward the front, which is something we can address a little bit later. So that's sort of just a quick overview of how you can get from a workflow setup to a result just in a couple of seconds. And this is something for perspective that with this level of accuracy would have taken many, many minutes and hours in the past. So let's then turn to the question we really want to know, which is how does this daylight sort of performance manifest over the course of the year? So I'll just delete this luminance result for now. And rather than watching me step through and name all of these individual rooms, I've already set up grids to accommodate. So here I basically have sort of open office spaces in the south, reception area, conference rooms in the east and west, and more open office and a conference on the north. So let's switch gears and think about the whole year. So this is basically, we're now running the point in time analysis we just saw, but overall 8,760 hours of the year. And along with that type of analysis, we can pull up sort of compliance the number of metrics. So you can look at LEED version 4.1 or 4, or other metrics, and we're kind of continuously adding to this. So I've actually already set up most of the inputs I need for this model for the point in time simulation. The only thing I need to add is the blinds. So when I go here, I can select window surfaces that host blinds. So I'm just going to go to my glazing layer in my base option and select all the windows. And now I have an option of different types of blinds. I can look at dynamic glass. I can look at operable blinds, which consist of a list of woven shades here. I'll just leave it at the default, which is something kind of like a Mecho shade. And now I have all the inputs I need. So what we've described here is a full office floor plate, fully glazed facade. And the question is, how does this perform from the perspective of those two questions we asked earlier? So daylight sufficiency and comfort. Daylight sufficiency will be answered by this workflow, and we can kind of dive into the details of comfort a little bit later. But if I click run, what's going to happen is the same type of back-end ray trace we described for point-in-time illuminance will happen here on an annual basis. And this is actually where we've really made breakthroughs in the speed department. So in addition to this path tracing approach, we're also offloading some of the calculations to the graphics card, which allows us to run these calculations very quickly. And so what you can see is, as with the point-in-time workflow, we're getting results back very quickly. And what you're seeing in the viewport as a default selection here is the daylight autonomy. So the green areas are areas that are receiving at least 300 lux for more than half of the occupied hours. And the gray areas are receiving that quantity for less than half. Now, if we look at the scorecard up here for LEED, we can see that we have 2 credits because we've exceeded 55% SDA. So I guess we could say that we're done. But actually there's an asterisk here, which is important, which says that we have an excess of annual sunlight exposure. Now, if we had been doing this calculation versus LEED 4.0, we actually wouldn't have gotten any of this daylight autonomy credit because of the way the accounting works. We would have been docked or penalized because of our excessive ASC. LEED 4.1 has gotten a little bit more permissive, but you still have to provide an explanation of the areas that are overlit and how you're controlling for glare. So let's look at the ASC issue for a second here. So if I switch over to the ASC metric, what I can see in the viewport is now a map of the places where we're receiving too much sunlight exposure. And that's quantified as areas that receive 1,000 lux direct for more than 250 hours in the year. At this point, we really have 2 options for LEED accreditation. So one is we can argue that the places where we have too much direct sunlight don't affect work tasks. So, we could design an interior layout such that these areas don't fall on work surfaces. That's going to be pretty hard. It looks like in the southern zones, we actually have about half the area is overlit, and it's pretty much guaranteed to fall on a work surface. So that's not a very believable story. The second thing we could say is that, you know, we've provided blinds in the simulation, and actually we're going to specify mechanized automated shades here, which will solve the glare problem. And if one looks down at the table of spaces below the graph here, you can see itemized sort of what the annual sunlight exposure within each space is. So we see indeed for some of these southern spaces, we have sunlight exposure around 40%. That by definition is measured without the blinds. But in the column next to it, we see what the sunlight exposure is once you account for blind operation. And there you see what you'd sort of expect, which is that the blinds are in fact taking care of the glare issue. Now, two problems with that approach, as you can imagine. So one is if we are relying entirely on a specification of automated shades to get our lead points, we're putting in the hands of an item that can easily be value engineered at the end of the project, all our hopes and dreams. So this maybe isn't the best and most integrated design strategy. It's also, frankly, just bad daylight design. So if we go back and look at the spatial daylight autonomy, we can see that on those southern facades where the blinds are in constant use, so if we actually switch over to the blinds category here, we can go down and see that in the southeast office, for example, the blinds are open only 70% of all occupied hours. And if you look in more detail at the annual map, you can see that in the winter months, the blinds are generally closed for about 80% of the workday, anytime it's sunny. As a consequence of that, the spatial daylight autonomy suffers. You can see here in the north facade, we're getting full daylight. On the south, we're only getting about half the leaf span or less with daylight penetration. And that's because the blinds are always closed in the winter months. So what can we do about this? As I mentioned, the idea here is that we're sort of in concept, we can play with other facade design options. It probably shouldn't surprise us if we're familiar with daylighting that a fully glazed facade is not the best idea, even though initially you might think more glazing, more light. There's obviously more nuance than that. So as with the point in time workflow, you can see these numbers have actually stopped changing, even though I sort of keep running passes to make the result more and more accurate, so we can stop this at any point. And now I want to look at some other design options. So taking the lessons that I've just learned from our base case, so we'll actually maybe for reference call this result base case, which is fully glazed. What could we do? So I think one lesson is we need to actually address the direct overlighting condition. So we need to provide some sort of external shading. Now, in the spirit of this idea of integrated design, it might be worth considering something that doesn't just tack on to the exterior some shade that can be value engineered out. So I obviously am not going to model this live, but beforehand, like a Julia Childs show, have pre-baked something that we can test. And so back in my layer structure, I have, in addition to my base case, I have this option one. Okay, and what this is sort of a design idea about moving the structure to the exterior and then going to a punched opening facade. So I know that I had ample daylight in my base case option, and the real problem was overlighting due to direct sun. So what I'm going to do is I'm going to move the structure out. This actually opens up layouts in the interior for more flexibility. And it also provides some self-shading. So sort of where the column cladding comes around can form vertical shading, and where spandrel beams and horizontals meet them together, we get some horizontal shading as well. So I can also kind of tailor that design to orientation. So the south may have a sort of symmetrical punched opening like you see here. And then in the east and west, I may do more of a sawtooth pattern to protect against what I know intuitively to be sort of the southern direction of the sun. Now, if I don't know that intuitively, there are easy tools in ClimateStudio that help me figure that out. So if I go to site analysis here, I can, for example, turn on a sun path diagram. So I'll make this a little bit bigger so we can see And what this is showing is the direction of the sun for any point in time throughout the year. So this is the winter solstice at noon. So I see in the winter months, I'm getting this very low angle sun arc. It's sort of, the sun is always setting in the south. The other extreme would be the summer, right? Where the sun starts actually, you know, east of north, or sort of north of east, and then moves sort of again towards the south. So in general, this intuition to predict the sun from southern directions is good. I can also kind of visualize this by turning on shadows in the viewport, and I'll put a cap on the roof here so we don't believe that our space is transparent on the top. So looking at a summer day, for example, here we get at noon, right, the sun is high, right? So we're actually getting nice shading on all facades, and the sun gets up pretty quickly. So that's sort of useful throughout the day. And then also, you know, in sort of more transitional times to the autumnal equinox, right, I'm also getting some of this protection from the south by the vertical members on the east and west. So this is kind of an intuition. Obviously, to bear it out, we need to look at the actual data. So I'll turn these off and go back to my previous viewport settings. And now, of course, I have to assign blinds to the windows in my option 1. So going back to the daylight availability workflow, I can set blinds here by selecting my new glazing surfaces in option 1. Okay, and I'll use the same type of blind as before. Now, because I've reduced the window to wall ratio, which I presume will also have knock-on benefits for the energy performance of the space, I want to increase the visual transmittance. I'm also providing shading against the direct component a little bit and discriminating between sort of high angle summer and low angle winter sun. So at this point, maybe letting in more light through the glass would be better. So here I've switched my glazing type from something with about 40% VLT, which might be reasonable for imagining a fully glazed tower, up to about 60%. So that's the other thing I've tweaked. So now if I run this, it'll go through the same process. So it's doing, I should also mention that this annual workflow, for those who are familiar with how these things work, is pretty similar to the 5-phase method. It's actually in certain ways a little bit more accurate, which I can get into if people care to get into the weeds. But what we'll see right away is that despite the fact that we've decreased the window to wall ratio, the spatially daylit area has actually increased, right? So if you recall, in the base case, we had about 73% of the entire floor daylit. Now that's gone up to about 90%. And you can see the bulk of those savings or those performance improvements have occurred in the south zones. And that has to do with the daylighting story. So what we did is we've cut the annual sunlight exposure in half. So in the base case, we had 24% ASE over the floor plate. And this one, we now have less than 12%. And you can see we've done a pretty good job with the punched openings of keeping sunlight off the workstations. We may have still some problems in the first row of desks or so, but it is a dramatic improvement versus what happened before. And I still have this little asterisk because indeed some of these southern spaces are over the 10% ASE threshold, which can be quite hard to meet. So we can now at least provide a more reasonable explanation of glare control. And then another way to answer those questions of comfort, though, is we could do a different type of analysis, which is a little bit more detailed. So let me pause this for now, and I'll call this option 1 to match my Rhino layer structure. Okay, so what is ASE really? Well, we're looking at direct sunlight that falls on a work plane. And this is a useful, but still somewhat crude indication of visual comfort. And over the past, several years of research in the daylighting fields, we've come up with improved metrics like daylight glare probability, and that can look more directly at questions of visual comfort. So I want to do one of those now with our option one and kind of see how we're doing in some of these perimeter areas. So if I switch over to an annual glare study, and this can be accessed either from the drop-down in the main workflow panel or from the toolbar. So if I click on the annual glare workflow, what it's really doing is just switching the drop-down in the workflow panel. And here I can see that my blinds input has gone away. So what we're looking at in annual glare is actually kind of the worst case scenario where the blinds are always up. And what this does is it helps us identify those moments where the static design is not solving the glare problem. So it's kind of a corollary to ASC. And here, since everything's already set up, all I need to do is click play. And if anyone remembers using Diva for Rhino to run annual glare, you'll recall that you would have set up a single view position and then probably after clicking the play button, hopefully at the end of the workday, gone home and then come back the next day to see what the results were. So now we're getting glare over hundreds of sensor points, each with 8 different view directions, again, just in a matter of seconds, using the new backend technologies. And okay, what does this map mean? So if I zoom in a little bit closer, I can see for each view position, and these by default are at 1.2 meters off the finished floor. So this is sort of higher than the work plane. So it's where you would imagine your seated eye level would be. And so for each of these positions, we're now giving 8 view directions. And for each of these view directions, if I click on one, for example, here, what I'll see is we're actually looking at an annual set of conditions. So for this particular position, this particular view, what I can see on the right-hand side here is a couple different graphs. So the top graph is showing me what fraction of the time is there glare in that view position, looking at binning it by times of day, or below if I look at actually all the discrete hours of the year. So this is a map at the bottom that goes from sort of midnight to midnight as you go down the y-axis, and then from the first day of the year to the last on the x-axis. And what I can see from this combination of graphs is maybe not surprising, but for this view on the south facade that's looking towards the east, right, I tend to have more glare issues in the morning, right, when the sun is sort of rising from the east and scraping across the southern sky, and in the winter when the sun angle is lower. So that should confirm some intuition about where glare problems occur. But then, what do I do about this? So the next step in the process could be to look at an individual point and start to think about geometric interventions that could help. So for example, if I were to sort of go to any of these red areas, so these are areas where we have intolerable glare coming in, and I can click on this render button. And what this is going to do is going to open a visualization in Fisheye Projection. So this is sort of mimicking what the human eye would see. And what's nice about these little render windows is they're actually dynamic. So you can spin around and see what the glare condition is in different directions just by clicking and rotating with the mouse. You'll notice what starts to come in here is a very grainy image. And this is part of the progressive path tracing technology. So if you wait, this will smooth out over time. You can also change the display type. So you can go from sort of a traditional RGB to a false color. In both cases, we've been flagging in this image pixels over 2000 candela per meter square. And so these are potential sources of over brightness in the image, right? And looking at the false color, we can sort of see the full range of luminances that we're getting in the image. Now, if I maybe increase the bounds, the upper bounds of this false color, I can see, I can narrow in on actually the parts of this image that are brightest, right? And so what you see here is there's a very large circumsolar region in the upper portion of the glazing that's probably constituting the biggest problem here. And we can tell it right away, so we don't have to wait for this image to get nice and smooth. If you actually look at the vertical eye illuminance in the DGP, we can see that those aren't changing. We've already sent out millions and millions of rays in this image. And so that sort of cumulative effect, that measurement, is already quite stable. So we know we have a problem in this moment in time, and we know it's in the upper portion of the glazing. And we can sort of step through and look at some other viewpoints and do a similar exercise to get a more intuitive handle on where the glare issues are coming from. But I might surmise that this is not atypical, right? So for the southern exposure particularly, you know, the sun's going to be spending a lot of time in the upper clerestory portion of the glazing. So a second design option I could think about is one that tries to diffuse that light while still keeping a vision area open. So I'll stop this for now because it's kind of giving me the answer that I need and close it. And I can also stop the annual pass, which had been going in the background. And I'll call this, well, I can still call it, so this is option 1, glare. Okay, so let's think about another design intervention. So I've also pre-baked something that I'm calling option 2 here, which is kind of a variant on option 1. I'll hide the results display for a second and turn on this guy. So similar punched opening geometry, similar sawtooth on the east and west. Although now what I've done on the interior is add static louvers in the upper portion, the clerestory portion of the glazing, and then a light shelf which sticks out into the exterior that separates the vision glazing at the bottom from the clerestory glazing at the top. And this is just to give me a little bit, I mean, this light shelf could be interior for lighting purposes, but for energy, I'm just going to guess that this might provide some shading benefit in the summer. So with that switch, I can then restart the glare simulation and see if that addresses some of the concerns I have about my option 1. Okay, so just to zoom out and talk about what these graphics mean. So when we zoomed in on a point in time in a particular view location, we could understand that what we're looking at was specific moments in time collected over the course of a year. So what we're seeing in the preview here in the viewport by default is just the statistical summary of that annual performance. So using disturbing glare as a threshold, we're saying, you know, okay, if you have no disturbing glare over the course of the year, then that view slice is gray. But if you have as much or more than 5%, then it's red with sort of a scale in between. So this gives us a quick visual summary to say, okay, all the red areas in my viewport are places where I have disturbing glare more than 5% of the time. And this is a number that sort of comes from a few studies on subjective satisfaction of spaces. It turns out that once people experience glare more than even a small percent of the time, around 5%, they start to complain. So comparing this option 2 to option 1, what we see is that percentage of problematic views has gone from 22% down to about 13%. So we've almost cut that in half. And now this is where having these view directions becomes very useful, because you can start to tell a story about interior layouts too. So we talked about imagining this as a concept design project where, you know, we're doing the facade, maybe the layouts aren't totally fixed. One thing that both of these maps indicate is that the worst glare problems happen, perhaps unsurprisingly, when you're looking directly out of the facade. So the way I've just schematically oriented the workstations to look parallel to the facade turns out to be a good one, right? So at these locations near the workstations that are near the windows, in general, if you look out towards the window, you can see in the map here, I have intolerable glare or disturbing glare really much of the year, almost every day that it's not overcast. But if I turn to the side, those problems are much more minor. So if I go back and just visually inspect that same time point that was causing issues before, what I'll see is a very different story. So that bright circumsolar region is now getting blocked by the light shelf and the louvers, right? And so what I have is, what used to be disturbing or intolerable is now imperceptible. If I rotate and look, right at the window, maybe it's an issue, but the way I've laid out the workstations, that's not a problem. So I'm pretty satisfied with this design of even sitting next to the window. We don't really have problems here. Of course, you might ask if, in adding all this extra stuff up at the top of the vision glazing, we've hurt our daylight performance. So maybe we need to circle back and answer that question. As we mentioned at the start, there's comfort, but there's also daylight sufficiency. So are we still providing that? So I'll pause this for a moment and call this option 2 glare. And I'll switch back my question to daylight availability. And of course I need to specify the blinds again. Now here I'm going to say that I don't really need blinds in that clerestory portion because it's always blocking direct. So I'll just pick within option 2 my vision glass. Okay, and so what you're seeing here is now we just have operable blinds on the lower part of the glazing, and the upper part with the louvers is just always has the fixed shading. Okay, so let's start that. Okay, so first things we see, first of all, dramatic improvement in ASC. So if you recall, base case, we had 24% option 1, about 12%. Option 2 now is down to 2%. We really only have direct sunlight hitting our work plane in the corner in these private offices and a little bit in the west, but it's actually not falling on any workstations the way we've currently laid things out. These corner conditions also I've kind of left without an external light shelf just for kind of aesthetic conceit. But obviously that's something we could address too if we really had to. So that's dramatically improved. Now let's look at the spatial daylight autonomy. Here we're actually still doing incredibly well. So if you recall the base case, we had an SDA of about 73%. Option 1 got us up to about 90%. Option 2, still about the same, so 87%, reasonably close. And so this is still getting us the maximum number of daylight credits. Now it gives me this asterisk just because, as I mentioned, those 2 little office spaces had more than 10%, but that's easily dismissible. And so what I have here is essentially, in a couple minutes, I've gone from a project that wasn't performing particularly well, where we couldn't explain the overexposure due to direct sunlight, to one where we have a pretty complete narrative of a well-functioning daylight space, in addition to the fact that we're getting dramatically improved daylight versus the base case. We also have a nice story about view, right? So if I look at the base case here, I remember sort of noticed that the blinds were down 15% of the time, and some areas down 30% of the time. In option 2, which I can stop here at any point, the blinds are down less than 5% of the time across the project. And even in the south zones, if I look here, they're open more than 90% of the time. So we have unobstructed views out, at least in the vision portion. And we've got ample daylight, and we have full lead credits. So once you have this, you can sort of quickly export a report here and get your lead credits just in a matter of minutes. Last thing, just turning gears for a second before we switch to questions, is I also want to show a little bit about electric lighting, which we haven't touched on here. So I'm going to hide all our results here, and maybe just focus on lighting design for one part of this floor plate, now that we kind of have our daylight and facade story ironed out. So I'm going to actually turn off all but one of these grids. So maybe I'll just look at this southeast open office area here. Now, if you go back to point in time illuminance, which is where you would study something static like a luminaire, I can see I don't have any luminaires visible. This is because I imported some into the scene. Just to show you how that works though, if I click on the Add Luminaires tab, I'll get a pop-up window here, which lets me select any type of luminaire that can be described in an IES file. So ClimateStudio ships with a couple of defaults which you can browse through here. I might pick something that's maybe providing both ambient upward and direct downward light. So I'll pick this linear suspended ambient indirect direct fixture. And I can preview it in 2 dimensions the way you can in some IES viewers. So I can sort of cut through the photometric web in horizontal or vertical section. A nice way to see that is actually just in the 3D viewport. So if I select this, it's going to add the luminaire to the model at the XYZ origin. And that's hidden right now just in my current display mode. So it drops it here. Now I can then drag this luminaire anywhere I want and then include it in a simulation. So rather than watching me actually place all those, I'll just turn on the luminaires I've set up in the model. And this is just my first guess at kind of a density array here. So sort of over the workstations in this area, I've got a row of 3 luminaires. And so what I want to do is see whether that's going to provide sufficient electric light on the work plane when we don't have daylight. So going to the point in time inputs, what I'll do is turn off the daylight. And the way I can do that is just by setting the hour to some nighttime condition. So I'll just set it to midnight. So I know I have nothing coming in from the outside. And now when I click play, the ray trace is just going to be looking for the artificial light sources. So the grid looks very blue here, suggests not very much light. This is because I have the threshold set up kind of for a daylight condition of around 2000 lux max. I'll bring this down to imagining I have a target lux of 300, right? Now I can see, and I can even turn on the values here. I can see that I'm lucky and that I've sort of pretty much reached that across the zone here. Now you may have a sort of a higher or lower target threshold deliverable, but let's just say 300 for now is good. What this lets us do then is segue a little bit into the energy simulation, which we'll be showing on Thursday of this week. We also have to provide some assumptions about lighting power density. What I can do here is actually establish what I need given a specific lighting design. So for this luminaire, which I'll say sort of I'm satisfying the 300 lux threshold with, given this distribution, I can just quickly look at the power of the light. So it's a 29 watt fixture. We'll just call it 30. And so if there are 12 of these, that puts me about 360 watts for this room, which if I click on it in Rhino and just ask what the area is, I'll get about 100 square meters. I can also see that in any of my results tables here. If I look at the Southeast open office, I can see the square footage. So in metric though, we have about 360 watts over 100 meters. So we're looking at a light and power density of about 3 to 4 watts per meter squared, which we can then sort of plug into our energy assumptions. Given that we only have about 10 minutes left, I think I'll pause there and open it up for questions. I think Christoph has been kind of paying attention to those and maybe can act as moderator.
Yes, my pleasure. Wow, you guys kept me busy. So I answered 56 questions, and the 3 I haven't answered, I will do as soon as I can. Thanks a lot, Johnny. That was great. Please keep on posing questions as I go through a larger group of questions that we heard from you. You should have seen my answers as I typed my answers. I think in all cases, they were provided to all of you as well, if you want more details. But taking it from the top, the first question was about whether the Rhino ClimateStudio workflows are or will be compatible with Grasshopper as well. And then the answer is yes. Actually, everything we're going to show you on Thursday for the ClimateStudio energy part is already fully implemented in Grasshopper as well. For some of the new daylighting features that John just showed to you, we are planning over the summer to implement them into the Grasshopper environment as well. And then there was a whole series of questions whether these results could be combined with optimization tools such as Galapagos or Octopus as well. And again, the answer is yes, of course, once they're in the Grasshopper environment. There were a series of questions regarding other daylight availability metrics, if we're going to add them, and such as useful daylight illuminance. The European daylighting standard came up a couple of times. Again, the answer is yes, we are. This is actually happening right now. So I would say in April, maybe early May, we have a custom workflow that allows you to kind of mimic the whole bandwidth of different daylighting standards that are annual illuminance simulation based. And we'll more specifically put the elements of the new European daylighting standard in very soon as well. Yeah, there was a couple of times a question regarding why the simulations results are so fast. John spoke a little about this. I guess I would say in a nutshell, what you should know is these results are based on radiance. And if you wait long enough, they will be converging to the exact same numbers as you would get out of radiance directly, with the difference, of course, being that radiance is a stochastic program. So you would basically, in both cases, have to run the numbers a number of times, and then you should kind of overlapping curves there, distribution curves. The difference, again, is, as John pointed out, we're using path tracing, which is a method of getting the results very quickly. What that means is that as you follow the results on screen, you see them changing quickly. And as you see the results changing less and less, you know that they have converged. And once we notice, or the tool notice, that the results don't change anymore, the tool is stopping by itself. So in a nutshell, we're using radiance with the three-phase method. Question regarding compatibility with Revit, Archicad, and SketchUp. This question is, of course, something that we get all the time. We know there's a key interest in that, and we will be tackling that also this year. We had some discussions with our executive members on that. Any ideas that you want to share from your end with us, please by all means email us directly, and we are happy to take on any thoughts and workflows that you find are good. Another big question was custom materials, and there the answer again is yes, you can add any radiance material that you want and use them in the pull-down menu. We haven't shown that here, but it's possible. And of course, if you're interested, we're providing a workflow for that, how this is done. Yeah, I guess, oh yeah, here, perfect, yeah. Here you see John just opened it. If you want to add your own custom materials, you have to know what you are doing, but again, there are absolutely no limitations to what radiance material you'll be adding to any layer. Another question was, I think that's a good comment, daylight factor, if we can calculate that right now. We can't calculate at this moment in time daylight factor. That should be very simple for us to implement, and I put it high with an exclamation mark on our to-do list. You can already do a point-in-time illuminance. That's one of the workflows similar to what you've just seen for the electric lighting analysis. If you were to use a CIE overcast sky, you would basically get the same calculation as the daylight factor. You would just have to normalize it, and that's something that we can accomplish. Question on view metrics. We currently don't have view metrics implemented a la European Daylighting Standard or LEED, but that's high on our radar. I think these metrics still have to kind of converge a little bit and become more reliable by themselves. PDS reporting, CSV exporting. So yes, we don't want to have too many clicks and buttons and whistles there, that the GUI stays clean, but we already started having adding the ability to write CSV files or create custom reporting PDF files out of the software. And if there are any specific requests, we are very happy to accommodate those. So we have no, we want to give you all the data that makes sense. The caveat being here, of course, this data sets can be very, very large. This is why we store them in binary format, because if you imagine for every sensor, for every workflow, you look annual illuminance in 8 different directions. These are massive, massive data sets, but we can support them all. Question was in how far, what's the relationship between ClimateStudio and Diva? We are, of course, honoring all existing Diva licenses, and we will fully support and maintain Diva until at least the calendar year. You can use your licenses in perpetuity. We will be focusing most of our efforts on the ClimateStudio tool going forward. We don't have a Mac version right now, even though we are using Macs. I think we'll get to it at one point. We just, in the professional world, haven't gotten the request as urgently as many of the others that were just raised. Questions on color editing. Yes, that is possible. Some of the colors you can already edit, and we just talked about yesterday how we'll make that to you available in a custom panel. Documentation is high on our mind that we'll be adding to that. Maybe at that point, John, if I couldn't be made presenter, then
yeah, you can.
Yeah,
grab it now.
Yeah, perfect. Thanks. So we already have some video tutorials for the energy for the daylighting components. If you go to the Solema website under Training ClimateStudio, you will find very short and succinct video tutorials by Jeff Geisinger, who also the voice of Diva, who already did the tutorials for Diva, now has made these tutorials. They are very short, and this is by design because we want you to very quickly use them and implement them in practice. And but again, I know we heard that documentation is obviously key, and we're still working on this. Regarding costs, next steps, if you want to try the software right now today, just request a license. Go to the Solema site, click on request a license. Pricing is based on an annual subscription model, and just the first seat pricing is dependent on firm size. So there's a little form. If you fill that out, we'll get back to you right away. If you're an educator, we have an ambassador program for educators. ClimateStudio is free for all universities and students, including university computers. If you are an educator, just contact us. There's a special link under the website for this. We'll be setting you up with a license code for your university, and as soon as you or a student are on your university network, then the license will be switched on always for a week at a time. So again, there we have a whole series of educators already using the tool, and yeah, just contact us if that's of interest. Sorry, I'm just trying to see if there were any other questions. There were some questions regarding control of the DG of the daylight glare probability and linking it to blind schedules. Obviously, that makes total sense, and that's something that we will be adding. So similar to under the daylight availability, you will then have the same setup for the blinds, and then you will see the effective annual glare results based on the setting of the shading systems. You can define as many, or the tool defines as many different shading groups as are necessary. So if you have different window orientations, the upper lower parts of the windows, different shading systems, electrochromic systems, we implemented the data from some of our executive members. That's all possible. There's no limitation. In terms of the control of the shading system, we have the simple lead control implemented right now, but you can implement your own comma-separated value schedule as well. And we'll be adding some more generic other controls as well based on temperature and so forth. Let me see. In terms of hardware that you need, you just need a common laptop with a graphics card. Can be any graphics card that you want. No special requirements. Timur, Dogan, Alstan, Jakubiec, and I have been using ClimateStudio last term for teaching. That went very well. Better hardware is of course always better, but there's no, in principle, no limitations there.
Yeah, I should jump in on that point.
Yes,
and say that, well, I had intended to conduct this demonstration from my nice, powerful desktop at work, but of course, complying with the ethical responsibilities of COVID-19 lockdown, I instead had to do it from home. So I did all of that you saw today on a laptop, which is 5 years old and is kind of a piece of junk. So all to say that, yes, better hardware is better, but you can do all these things quickly, even on an older machine.
I did not receive a link to download the trial version. Yeah, you have to request the trial version. If you go to our website, click on trial version, then it should take you to a form. You fill out the form and then you get the trial version. Again, contact us if that isn't clear. It's basically here, if you just go to Lemma ClimateStudio, they have these different options, video tutorials for educators. We will be adding links to the webinar both from today as well as on Thursday here for you to get back to that. And just keeping track here. Great tool, thank you. We love the tool. We've had so much fun developing it, and I'm always so happy when I open it in the classroom and I just can focus on content rather on how to set material properties. And actually there was a question a couple of times, the simulation parameter settings for radiance that we are using. The simulations that you saw were with an ambient bounds of 6 and an ambient accuracy of 0. The 0 we are setting due to the path tracing approach that we are following. You can change this when you go to the settings under the different workflows. Let's see. If I forgot anything, you can type it now. Can you change units to foot candles? No, I'm sorry, we can't do that right now. I know this is on our mind. We understand that, especially on the energy side. Units change, and we'll take that request to heart. Oh yeah, question of what are we using? Are we using DASIM or using different methods for annual calculations? We are using actually the 5-phase method, or version I should say of the 5-phase method, so not DASIM per se anymore. For simple cases, DASIM and the 3 or 4 5-phase method should lead to identical results. Of course, the method has some inherent advantages when it comes to complicated situations with different shading groups, because they are just doing matrix multiplications for different BSDFs for different shading system settings is substantially faster and allows us this very quick near real-time analysis that was just shown to you. I cannot show the lead report right now. There's a question here. We are still working on that, but again, that's something that we of course understand that you want this in a nice PDF format. We have a prototype for a PDF report generator that we had used at an earlier point with our members, and based on the we were bringing that back in now.
Yeah, the current one is the one that I showed. That's just a CSV file, but as Christoph mentioned, there will be a prettier version coming next month. Yeah.
Oh, Danny Pearl, that's so nice. Hi, Danny. Can you model Solera? If you have a Solera Radiance file, we can model Solera, yes. No limitations there. Email me if you want to know how to do that. How long's the trial? The trial is several weeks, and they are just, if you have questions, contact us, talk to Jeff Niemasz. That's what I had. If there are any, if I forgot you, it wasn't on purpose. Give you one more opportunity to ask questions. Yes, you can use BSDF functions if you want to do an annual glare and point-in-time illuminance analysis. For the like between the energy modeling and the lighting models, do we need okay, that's a good question. What's the link between the artificial lighting and the energy analysis and in the daylighting analysis? The link is right now not automated yet, but as you just saw, Jon was doing a daylighting analysis, an electric lighting analysis, and helped us to set a proper lighting power density. On Thursday, actually, we will be picking up from what we left off here and use the lighting power density from the daylighting analysis to explore what impact that has on the thermal side for heating and cooling and so forth as well. We are, what time is it? We are a couple of minutes over the hour, and I realize that we want to finish in time. If there are any more questions, please contact us. We're of course thrilled if you give the software a try. Remember to use the latest version of Rhino 6. And right now you have to use Rhino 6 under Windows. There's no Mac version available at this moment.